Hello. So good morning. So today we will discuss about the mirror formula and we will derive it. So let us take a concave mirror and the midpoint is called the pole. Now you know that suppose this is your center of the curvature of the mirror, then the line passing through the center of curvature C and the pole is the principal axis. Now take a object beyond C. Okay. Now this object, suppose let us draw it. So the parallel ray, as you know, the parallel ray will pass through the focal length focus. Okay. So now this and also you know from the laws of reflection that the angle of incidence is equal to angle of reflection. So let me draw another ray to the these rays are of my choice because these are the best suitable rays, that's why I am choosing these rays. Okay. So now it will intersect somewhere in between your focus and your center of curvature. Now this is your image, right? This is your object. Let me name it A, B, and this is suppose A dash B dash, right? So I have taken two rays. One is the parallel ray to the principal axis, another is striking at pole. Okay. So this angle is equal to this angle because angle of incidence is equal to angle of reflection. That is the law of reflection. Now this is the parallel ray. I will take another ray which will pass through your center of curvature. So as you know, the ray which will pass through the center of curvature will be perpendicular to the, it will be 90 degree because it will perpendicular to the tangent. You already know if it is a circle, then the tangent is perpendicular to the radius. So as the ray which I have taken is passing through, let me draw it perfectly, is passing through, okay, is passing through the center of curvature. So that means it is a radius. So radius will be perpendicular to the tangent, right? So this angle will be 90 degree. Now this is, try to look carefully. My diagram is not that much clear, but still you try to see it. Now you see that I have taken three rays here. One is the parallel to the principal axis, second one is striking at the pole, the angle of incidence is equal to angle of reflection. The third one is the ray which is passing through the center of curvature and it will reflect back to the same because it is in the incident angle, it is striking on the perpendicular to the mirror. So that's why it will come back with the same direction. The angle of incidence is 0 here. Okay. So now let us derive it. Our target is to derive the mirror formula. So how will you go? So now you have to use the concept of similar triangles. So let us do how will you do? So let us name the points. Suppose this point is M. Now consider these two triangles here, A dash, F and B. This triangle, consider this triangle. So your image is as A dash B dash, your object is AB. Now this A dash B dash, this image, the distance from this image to the pole is image distance, will represent is at B. The distance from the object to the pole is represented as U, the object distance, and the distance from the focal length to the point P, it is we represent is with F. Now consider this two triangle, though it is not looking very clear, but try to draw it yourself and try to analyze it. A dash, B dash and this point, suppose F point. Now in triangle A dash, B dash and F, okay, A dash, B dash and F, and we will consider this triangle. We will consider that PM and AB are equal, okay, and it is also 90 degree. So in triangle FMP, F, M, P. A does, B does, F, right? And we'll name it similarly. So A does, B does, F, and your A, F and M, P, F, M, P, F, M, P, F, M. So in these two triangles, your this angle is 90 degree, this angle is 90 degree, these two angles are opposite. So if two angles, corresponding angles of the two triangles are equal, then the third angle must be equal. So we can use our similarity concept here. So how will you, what will be the ratios of their sides? So the ratios of their sides will be equal. So I can write easily that A does, B does by PM, this by this, because they are corresponding, is equal to A does F, A does F, A does F by your PF, right? A does F by PF. So this is one relations. Let me write, this is equation 1. Now I will consider again another two triangles, that is A in triangle A, B, P, and this triangle A does, B does, and P, A does, B does, P. Now in this two triangle, you can see here that what will be the A does, B does, A does, B does by AB. AB is the object height, A does, B does is the image height. So image height by object height is equal to, we can write that A does P by AP, by AP. Now this is equation 2. Now from 1 and 2 you can easily see that your left hand side is equal, because you can write this PM, you can write this PM as AB, because PM and AB a parallel rays, this is a parallel ray, so it will PM and AB approximately equal. So we can write A does, B does by AB. Now you can see from equation 1 and equation 2 that left hand side of the both the equations are equal. So what we can write from equation 1 and 2, from equation 1 and 2, from equation 1 and 2, what we can write? We can write that A does F is equal to F by PF, A does F by PF is equal to A does P by AP. Now what is A does P? A does P I can write, A does F can I write from here to here, A does F, can I write this A does F is equal to AP minus this one, so it will be remaining. So I will write A does P as, because I need a relationship between U, V and F. I need a relationship between U, V and F. That's why my target is to change all the parameters in U, V and F. So as AF has no meaning, so I need relationship in U, V and F. So I will convert this one AF to AP minus PF. So this will be A does P, A does, this will be A does P minus, A does P is the image distance minus PF. PF is the focal length by PF is equal to A does P by AP. Now we will use our sign convention. That sign convention says that if you are checking if the rays are from left to right, so we will use the Cartesian plane. So in the Cartesian plane, what happens? Now everything in the left side is negative, down the axis it's negative, above the axis it is positive. So we will our U will be, object distance will be negative, your image distance for this case, because the image here formed is a real image in the left hand side, that's why we will take here image distance as also it's a real image, so we will take also the image distance B as negative, and focal length for this concave mirror will also be negative. So now we will use the sign convention. So in the sign convention, what we will use? We will use your object distance that is here our AP will use minus u, image distance is a dash p, which will write b minus b, but remember this minus b will not be always for not all the mirrors, it will change. So focal length for your concave one, this case, so focal length is in this case minus f. Now put all these values in this equation. Suppose this is equation number 3. So now putting everything in equation number 3, so my AP A dash P is minus b, so minus b, and phi f is minus u, so minus, so this will be plus u divided by pf. Pf is your focal length, so this will be minus f is equal to A dash P by AP. What is A dash P? A dash P is minus b, and what is AP? AP is minus u. So now this minus will cancel out, so let us cross multiply it. So cross multiplication, let us make the cross multiplication. So this will become, this is b, right? This is b, A dash P is b. So now if we cross multiply, this will become minus bu plus minus bu and pf. What is pf? Pf is, sorry, this is f, so minus bu plus uf is equal to minus bf is equal to minus bf. Okay, now what we'll do in this equation, we'll divide uvf in both sides. Now dividing uvf in both sides, what you will get? When we divide uvf, then what will get? Dividing uvf both sides of the equation, so what you will get? U cancel out, v cancel out, so it will remain minus 1 by f plus u will cancel out and ff will cancel out, plus 1 by v is equal to v cancel out, ff cancel out, minus 1 by u. So what we did? We divided uvf both side of the equation. So now we'll rearrange it and we'll get our mirror formula. So rearrangement, let's bring 1 by minus 1 by u to the left side. So this will become 1 by v plus 1 by u, 1 by v plus 1 by v, 1 by f will take it to the right side. So this is your mirror formula. So this is your mirror formula. So one thing you remember, this equation is valid for convex mirror and the other cases, like the case here I have kept the object beyond C, means center of curvature, this is C, center of curvature. So I have kept the object beyond C and your infinity. Now you can keep the object here, you can keep the object here also, or you can take the case of convex mirror. In all the cases, just your sign convention will change, but the equation, whenever you will derive using the similarity of the triangles, using that concept while you will derive, you will finally get, and using the sign convention, of course, using the sign convention, everything in the left will be negative, but down the axis also, because the height will be negative, and above the axis the height of the object or image will be positive. U, V and F, left side everything is negative because you know the Cartesian coordinate system. Suppose you will consider this y-axis as mirror and x-axis is your principal axis. Everything which will come on the first quadrant will be positive. That means your uv, whatever will come on the axis, will be positive. Height will be above the axis will be positive. And if everything in the left side, it will be here x is negative, so minus, and y will become positive. If height will be positive, but u, v, f, if things are there on the axis, it will be negative. Down the axis it will be minus, and this one will be plus, minus. So first quadrant, second quadrant, third quadrant, and fourth quadrant, you know the Cartesian, how to use the Cartesian sign convention, use the Cartesian system. So now using that one, our u, v, and f, all the three, in this case for the concave mirror having the object beyond C is negative. All f, u, and v, all the three quantities are negative. Now, and remember this formula is valid for all the mirrors. Okay, so in the next class we will discuss about magnification and lens formula. Thank you for watching.